Alrighty guys, so in this one we're going to look at transposing literal equations. So the method's the same as solving equations where we know the value for pronumerals or variables, but this time we don't have anything that's going to, for instance, go into this first equation. There's nothing we're going to substitute into A, D, C, B or E. Okay, but what we want to know is what this equation would look like if A was a subject, and to do that we're going to use our reverse bidmass method. Okay, and what I mean by that is A is buried in the equation. Okay, so we know what's happening to A. To dig A out, we basically need to go from right to left across there when we're considering the operations that are happening. So the first thing we're going to do, even though there's a subtraction in here, okay, you can see that there, even though there's a subtraction, this whole top line is basically being divided by 2b, so it's in brackets effectively. Okay, so the first thing that happens, you can see that brackets is on the end here, and division, when we're reversing bidmass, would come first. Okay, so the first thing I'm going to do then is get rid of that dividing by 2b. The opposite of dividing by 2b is of course multiplying by 2b. I'm going to times by 2b here, and I'm going to times by 2b on the right hand side as well. Okay, dividing by 2b and timesing by 2b cancel each other out. So what I have left at the end here is AD minus 6C equals 2BE. Okay, because obviously that should have a little times up there, just to make it clear. Okay, next thing we're going to do, now that the division's gone, the brackets that were there, they can be there or they can't be there. They really make no difference now, because there's nothing outside of them that's happening that's affecting what's inside the brackets. So I'm going to pretend that they're not there now, and you can see that if I run through my reverse bidmass again, we've got that the subtraction that comes up again. So subtraction is going to come before anything else there, because the only other thing there we've got is some multiplication between the A and D and the 6 and the C. So I'm going to do that subtraction now, and therefore I'm going to take, getting rid of the subtraction will mean I've got to add 6C to one side and do the same to the other side, because we want to keep it a balanced equation. Now if I add 6C and take 6C, that's going to equal 0 6Cs, so they're gone. And that leaves my left hand side with AD equals 2BE plus 6C on that side. Okay, next up you can see that we've got AD, which is A times D. The opposite of multiplication is to divide. I want to get A on its own, so I'm going to divide by D. And I'm going to do the same to the right hand side, where I divide this by D as well. D divided by D is just 1. 1A is the same as saying A. So that means we get on the left hand side, A equals 2BE plus 6C, and that's all divided by D. Okay. Now you could say that's in brackets as well, but it's not neat. You're not needing to write it in brackets if you show that it's all above the line or all the numerator. Okay, so that's the first example of how to transpose a literal equation. Okay, for this next one, it's the equation that allows us to change Celsius to Fahrenheit temperatures. There's a few ways we can do this. We're going to use the reverse bidmass method again. It's just when we get to the 9/5 part, there's a few different ways. So if you know a way that I'm not showing you, that's probably going to be fine as well. The first thing we're going to do is, you can see there's an addition. Using reverse bidmass, we want to get rid of that addition 32, and the opposite of that is to take 32 and do that to both sides. Plus 32 and take 32 is going to be 0, and then that leaves us with the equation showing F take 32 equals 9/5 C. Okay. Now, there's a couple of things that you can do here. You can either divide by 9/5 on both sides. That will allow you to then divide your left-hand side by 9/5. It's going to look like maybe something a little unusual, but another way you can consider it might be slightly easier, so I'll do it that way just as a starter, is that what's happening to C is that you could say, I'm going to rewrite this as, so 9/5 C is the same as saying 9C over 5. Okay, and that might make it a little easier for you to follow. So, what's happening to C? We're going to, it's been divided by 5, so we're going to, first up, multiply by 5. Okay, sorry about a little pause there, lost connection with my internet, and so hopefully I'm not repeating. So 9C, that's not like it's in brackets, so we're going to get rid of the 5 first. So the opposite of dividing by 5 is timesing by 5. So we're going to multiply both sides by 5. Okay. Now that's going to take out that, leaving our right-hand side as 9C. And this side, we've got to remember that it's the whole left-hand side that's being multiplied by 5. So we're going to go 5 and put F minus 32, okay, in brackets. Last step, you should be able to see what we're going to do next, is that we're multiplying by 9, so the opposite of that is to divide by 9. Do the same to this side. And we end up with having C transposed, and then our left-hand side becomes 5F minus 32, all divided by 9. And there you have it, that's our equation, transposed to find Celsius. Okay, you might want to have a try at this one first, and then, so pause the recording, have a go at it, and then I'll walk you through it. So it is Einstein's famous equation, E equals mc squared, energy equals mass times the speed of light squared. So, how this works, reverse bid mass again. Okay, it's a pretty easy one actually, even though I've got a squared in there. First thing we're going to do, with our bid mass, we know that the indices, pen's not working too well at the moment, it's better. So we've got an indice in there, and we've got a multiplication. So when we're reversing our bid mass to get C on its own, we're going to hit our multiplication first, so we're going to deal with that as our first priority. So opposite of multiplying by M is to divide both sides by M, taking out those two. Then slamming doors in the background if you can hear that. E divided by M now equals C squared. And if you can remember back to our Pythagoras, etc., you know that C squared, to get C on its own, the opposite of squaring something is to square root. So we're going to square root this side, square root that side. That means that those two cancel out, and we end up with an equation that looks like this. The square root of E divided by M is equal to C, which is the variable representing the speed of light. There we go. Hope you got something out of that. Hope it all made sense. Leave comments if you think it can be improved in any way, and yeah, keep on watching. Cheers guys.